She has more than 80 publications in reputed national and international journals and conferences, 10-book chapter in Springer, CRC Press, IGI Global. She is also co-author of 2 books published by NCRT of 11th and 12th and co-editor in 10 edited books. She has also organized 5 international conferences sessions, 3 faculty development programs, 1 workshop, 1 industrial meet in her experience. She delivered an expert talk, guest lecture in international conference and a member of review technical program committee in various international conferences. Besides this, she is associated with many international research organizations as associate editor, guest editor of Springer and Elsevier books, and reviewer of various international journals. Now, I would like to request Professor Dr. Divya Mishra ma'am to kindly present a token of appreciation to our eminent speaker, Professor Dr. Manju Khari ma'am.
As far as my session is concerned and your Atal FDP topic is concerned, more or less both are related to machine learning, deep learning, artificial intelligence. So as far as the communication, we had the topic which I opt is trends, what exactly going on in deep learning. And deep learning is a topic which enhanced from machine learning. So I start from the scratch what exactly deep learning is, how deep learning comes into the picture, and what are the applications which are going on as far as research is concerned, and what are the challenges and major trends which are going on as far as government recommendation and some research recommendation, what are the trends which are going on currently in deep learning and machine learning. So these are the topics which I am going to cover in my session. What exactly artificial intelligence is, how artificial intelligence comes into the picture, what is the evolution, then where machine learning lies after artificial intelligence, and how deep learning comes into the picture, because each and every topic have its own evolution. And once we know about evolution, then only we come to know where this particular topic lies, how we can use that particular topic, and what are the major challenges which came across while doing a work on a particular topic. Then what are the terms which we use while using deep learning, because deep learning has its own process, artificial intelligence has its own process. What exactly artificial intelligence is? Can anyone tell me, students, what exactly artificial intelligence is?
Machine does something
Be
itself.
seated, बताइए.
When machine does something itself.
Something itself intelligently.
Yes.
So we are actually adding intelligence into a machine. So artificial intelligence basically have only two concepts. One is input and one is output. Once we process it intelligently, it gives us some outcomes. So artificial intelligence have an intelligence to train a machine and gives some intelligent outcomes. We have number of inputs and we have some desired outputs according to the input. So we have to train a machine accordingly so that it gives us some good predictions or some good outcomes. So artificial intelligence basically lies somewhere between input and output. Whatever input we have, this is actually a process of computer. We have input, we have output, and we train the computer to do a particular process. So artificial intelligence is just entering intelligence into a machine with coding, with programming, or with logics. And we have number of languages which support machine to code it and give us some outcomes in an intelligent form, right? And as far as machine learning is concerned, because we are making machine intelligent, we are making machine to learn, so we have a specific process for that. And each and every process has some, because we have to give some input into it, that input is divided in two parts. One is labeled and other one is unlabeled. In terms of data, we have number of data in the world. We have number of things which are there and we have to label it. What is label? Like we specify that that particular input is required for this particular process. And unlabeled, we have to search it out what exactly we have to fit in to get a desired outcome. So as far as machine learning is concerned, because it is a part of artificial intelligence, so we have segregated the kind of data. And to train a machine, we require training. Why we use training and testing?
More accurate outputs.
For more accurate output. If we don't train the machine, then will not get outcomes, will it?
we do training basically like to feed the machine. Like this is this and this is this. Right? Like let's say we are given a bunch of like apples and oranges. If the machine doesn't know what is an apple and what is an orange, so when I'm giving a new output, like if it's a banana, it won't be able to classify like it's a banana or it's an apple or it's an orange. So that's why we need pre-processing.
So more or less it is learning, right?
Yeah.
It is learning. So what we are doing, we are doing something so that machine will learn what is apple and what is banana. So for that we require input, and for that input we segregate the input in a labeled and a non-labeled form, or in a labeled and unlabeled form. And for training and testing, why it is required? As he said, we require to train the machine. हमें बार-बार बताना होता है कि this is apple. Then machine can predict at the end, at somewhere stage, yes, this particular object is an apple. So they trained it, and why we test it, why we segregate 70 and 30%. That is a like predefined kind of scenario. We have a 70 and 30% division that we train the machine, we test the machine in a percentage of 70 and 30%. Why is that so? हम मशीन को इतना लर्न करा देते हैं कि वो 30% रिजल्ट अच्छा देगी ही देगी. But why we do that? If anything is telling to us like this is the particular definition, we learn it, we have to learn it, and we come up with that particular definition. So that is training. We are training, and again 70% we train and 30% we test. Do we change that percentage? Do we change that ratio? Is it required to change that ratio? Any ideas? Any clicks? We can change that. Like if we have a huge data at that time, because we have already trained the machine, we can change that data. But we change it 80 to 20, 70 to 30, or sometimes 60 to 40. But it depends on data to data. As far as machine learning is concerned, we have labeled data, we have some learning algorithms, we have machine learning algorithms. How many machine learning algorithms we have? We have a number of machine learning algorithms. Can you name them? TensorFlow is a platform, beta. Machine learning algorithms. Random forest, KNN, RNN. We have so many algorithms, and we have hybrid machine learning algorithms too. From where hybrid algorithms come? With a combination of best machine learning approaches. We use the learning approaches, we combine them, and we use them for our desired output, whatever output we have. So as far as machine learning is concerned, we have number of learning algorithms, and on the basis of that learning algorithm, we design a model which gives us outcomes on the basis of our desired output. Like if I want to predict rain, then what I have to do is, what will be the input? The data of a particular state or a city or a region, the rain data is the input. What will be the algorithm? We have so many algorithms, so we can apply any algorithm which suits my variables, which suits my values, which suits my data. Like data fetch with the help of algorithm, and then it gives some predictions. And for that we have to decide some parameters. That comes in model. Parameters are like we need to know about the moisture, we need to know about the drop, we need to know about the weather condition, we need to know about the soil condition, we need to know about so many parameters. Those parameters will be added in the model, and that model gives us some predictions, and that prediction is your rain forecast prediction. So that way machine learning works. And as far as machine learning, the basic part, it is divided in three basic these terms. Now we have federated learning, now we have so many other learnings also. But as far as the basic part is, we have supervised, unsupervised, and reinforcement. Supervised while working with machine learning, the major problems are these four. Like one is the classification problem. What is the classification problem? What is classification? Classifying the data, right? How we can classify a particular data. That is the major problem. Like we have number of problems in this world, and all the problems divide in some segregated form. We have classification issues, we have regression issues, we have clustering issues, and we have anomaly detection issues. As far as my research domain is concerned, this is my research domain, anomaly detection. But in terms of in a broader form, we have these four major problems which deals with machine learning. We have classification issues. In this, we have usually discrete values, and on the basis of those values, we have to define a particular algorithm, or we have to decide which algorithm is to be used on that particular data, right? Then we have regression. Regression is basically we have to relate all the variables with each other. And for that relation, for time series work, for time sequencing, we use regression problem. Not use. These are the problems which comes with time series. These are the regression. And in regression, we have some variables to like. We have to define what is the relation between two variables. That problems comes with regression, right? And the next one is clustering. We have to define some groups of data, and that group is decided by clustering, and that is clustering issue. Then we have anomaly detection. Anomaly is anonymously detected issues like fake images. They comes under anomaly detection. Fake issues or some unauthorized things is to be happened, that comes under these problems. So these are the major problems which we have with machine learning. Although we have so many problems because research is a big pool, but majorly they are classified in 4. We have so many more, but they are sub part of it. Clustering, regression, classification, or anomaly detection. Then usually this is a scenario where we can apply ML algorithm and we get this kind of output. What is that? समझ क्या आ रहा है इसमें? That is input. Usually we have data points as an input. When we give input to a tool, we have data points as an input. And what algorithm will do for us? They do something, some calculation, which is background at the platform, and with the help of like nearest neighbor is one algorithm, linear SVM is one algorithm, decision tree is one algorithm, and navy base is one algorithm. Have you ever seen TensorFlow platform? Any of you? What that TensorFlow क्या करता है? What exactly it do? Why? बताओ.
Algorithms implement करने के लिए जैसे नाइफ बेस या फिर रैंडम फॉरेस्ट algorithm fake things को detect करने के लिए इस्तेमाल.
But how we detect that? Like, can you analyze what exactly that data is representing with navy base?
नाइफ बेस में हम टेक्स्ट वाइज डिटेक्ट करता है कि वो टेक्स्ट को देखता है और टेक्स्ट के बेसिस पे डिटेक्ट करता है कि अगर फील्ड में टाइम
Detect करता है, that is fine. But we have number of data points. We have data. We have number of algorithms. What we are getting with these images? Do we are getting something? We see whatever objective we have. According to that, we search our data points. If we want a linear line, if we want linear line, then we go for linear lines. If we want some clustering data, then we go for cluster data. That is not possible that each and every algorithm, each and every machine learning algorithm can perform its own approaches and gives us 100% result. That is not at all possible. So whenever we have input, we have to decide machine learning algorithms according to the variables, according to the parameters, and according to the objective which we have to find out, or according to the goal whatever is desired. Like if I want to detect a fake image, then we have to apply some other algorithm, not these 4 algorithms. We have number of algorithms in a machine learning algorithm pool, and we have to decide all the algorithms according to the parameters, according to the input we have, according to the objective what we have to define. Do you aware about objective function and fitness function? Each and every algorithm have its own objective function. Do you know that? हर algorithm का एक objective function. What is that? What is that? Objective means our target. Our objective to find out an outcome of a problem. Whatever problem we have, each and every problem can be solved with some objective functions, and those objective functions are defined in all algorithms. How we decide that this objective function is good or that objective function is good? Can we decide that? If I want to add 2 variables, then what is the best process? Just to add that addition point. That's it. That is the best way. ये हम सबको पता है. But while deciding an objective function, we have to select some objective function which gives us a good outcome. Good means optimal or the best. How we decide optimality? Which solution? Like I'll give you one case. I have one address that is Jawaharlal Nehru University. How you find out me in that Jawaharlal Nehru University? Problem is to find this particular faculty. How you find me? And you have only one, you can say one input, that is GNU. How you find me? Give me some input. How you search that?
on GNU website.
That is one thing that you know GNU. That's it. Then you have to subdivide the problem. GNU, department, then number of faculties or number of faculty or a particular domain you segregated. And if you want to find out my address, then what will you do? Then you have to find out where I stay, my zip code, or the details of a particular faculty or something like that. You have to subdivide the problem. So for that, subdividing is basically layering the problem. Layering means you have one problem that you have to find the address of a particular person, and after that you layered it. That is why deep learning comes into the picture. Machine learning have its own aspects to give the solution according to the problem. We have inputs, we have process, and we have some outcomes. But to find out a better solution, we have to layer it, and then deep learning comes into the picture. Deep means digging a particular problem more deeply. Like you have only Jawaharlal Nehru University, that is one problem, right? Or we can say that is one input. Then the department, the faculties, then the domain, then female or male, that you have to find out. Or this particular name, maybe there may be another faculty who have the same name. Then you have to segregate it. Okay, maybe this faculty we are searching for. Then the address. So these digging a particular input is deep learning. Learning, machine learning, you're giving some learning approaches to the machine. But deep learning is digging that particular input more and more. That is deep learning. So we have number of layers into it. If you are aware about the TensorFlow platform, they gives you add-on layers. Like आप उस platform पे जाके देखिए. In that particular platform, there is add-on layers. Like you can add the layers and see the outcomes. What exactly outcome will be. Right, so that is deep learning. Deep learning is basically a part of machine learning, but digging more information, digging more inputs is deep learning. Then how the deep learning comes into the picture? Actually, it works on the basic principle of brain. How brains work? It works on neurons. What are neurons? Neurons are small cells which are there in our body. Neuron, how they transmit? Like some signals. One neuron can send the information to the other neuron, and with the help of that information, the message passes in the body. Right? Similarly, the brain works. Brain have some neurons into it, and the neurons are connected to each other. Once the information lies with one neuron, it transfers to the other neuron. That way, the learning works. Like if we have one information, we segregate that information is passed on to the other stage, then digged into more deeper stage, and it works accordingly. So the working principle of brain is just work like machine learning, digging more and more as far as deep learning is concerned. Then this is just a trend, like if you search the term machine learning, artificial intelligence and deep learning, you come to know that nowadays deep learning is trending more. Why it is trending more? This is just a Google trend picture. I just put some terms over there and I find out this graph. This graph shows that deep learning is actually trending. Why? Because machine learning have single or 2 or 3 layers, but deep learning have multiple layers. Like people are digging the problems, digging the input and giving some output, or working for a particular problem in deep. That is why deep learning is trending nowadays. As far as AI, ML and deep learning is concerned, this slide is no more required actually, because we all know artificial intelligence is a broader domain, and in artificial intelligence we have machine learning, and in machine learning we have deep learning. So this is an image which I captured from image. How they work, how the different approaches work. Like if I have a problem which we discuss, we have a problem and that problem has some input or some rules which we decide to solve that particular problem. And we worked and they give us some outcomes. Right? Once we change our approach, or we can apply a classical machine learning, or we can say a basic machine learning, one map or one stage will increase. Right? And if we move towards deep learning, we have same input, we have number of processes. Why number of processes? There is a normal process. After collecting the input, we have to understand that input. What exactly input is? It doesn't mean that if you want to predict a rate and you have a 1010 values and you are going to predict a rate. No, it is not possible. You have to understand the input. How we understand the input? How we understand that? Like whatever data we have, it doesn't mean that data is relevant to your problem. Or whatever problem you are going to solve, that is relevant to that. How you understand that? That is fine, classification. You have to see that data. Is that possible that you can see the data all the time? No, it is not possible. Like once you get the data, have you verified the data that data is authentic data or not? Any one of you, how you verify that? Generic question, how you verify that? Like if I provide you some data and you use that data, you come up with some prediction. Is that worth it? No, that is waste because I provide you data. Maybe I manipulated that data and I give it to you and you use something, some machine learning, dig something more, come up with the deep learning and you have some outcomes. Is that work? No, it doesn't work. If you have a medical data, let's say, and some hospital is providing you a data of 2000, is that work? Standard, fine, standard से compare करना पड़ेगा, but the standard is required as well as the current scenario is also required. Like if we predict the data, whatever data is provided in 2001, can we predict today's weather forecast? No, we cannot. We require the real-time data. And how we authenticate that particular data is the original data? Like you find some data on GitHub. Can you verify that? See, GitHub is providing. We can verify. We can verify. How we can verify? We have some sources, like that data is used in some research articles or that data is used by some lab. So if they are using and they are coming with some predictions, it means you can use that data. But it doesn't mean that you can predict the current scenario. You cannot. For that you need the current data. And how you get the data, you will not get it. For that you need some kind of collaboration, or you need your mentor support, or you need something which is supported by the organization. Yes, this is the original data and you can go there. Right, so as far as first issue is concerned, you have to understand the data, and before understanding the data, you have to verify the data is authentic or not. If it is not authentic, your work is waste, your learning fight is waste, and your outcome is almost waste. Right, so first is understanding a particular data. Once you understand the data, then you have to understand your problem, what exactly you have to find out. And once you understand the problem, according to the understanding of a problem, you can apply the algorithms into it. Like it doesn't mean that whatever problem you have, you apply linear regression. No, you cannot. You have to understand the algorithm as well, because whatever input is going to the learning algorithm, that is related to the problem. Otherwise, it never matches. So you have to understand the algorithms parallelly. You have to understand the input and what exactly you want to fetch it out, like what exactly your desired outcome is. And on the basis of algorithm, you have to decide your objective functions, like what you want to fetch from it. You want to fetch moisture or you want to fetch rain prediction. That you have to understand it. So not data is the only thing which we work with machine learning or with deep learning. Data as well as algorithms, as well as the problem, you have to understand the problem. And once you understand the problem, then you have to apply learning approaches into it. And while applying the learning approaches, you have to understand how deep you have to learn your machine. Like we have 2 layers, 3 layers, and number of layers. But how deep you have to go to fetch them? Do you get 100% results after training and testing? Do you get? And in any case, if you get, your data is waste or your algorithm is waste, because there is nothing which gives you 100% result. Right? And then after that, you have to train a model. Why model comes into the picture? If algorithms works fine, algorithm अच्छा चल रहा है, data समझ में आ गया है, input is fine, problem is fine, then why model is required? Because model actually gives you the parallel parameters. Input is fine, problem is fine, but while you apply that particular problem somewhere, how you predict the exact scenario of that particular problem. Like if we talk about healthcare data, then for healthcare data, we required more parameters to learn about that particular disease. And these parameters you get with the help of platforms. Right? Once you get, because you can compare with the help of platforms. Platform have same input, multiple algorithms, and comparison of your outcomes. You get the differentiation of the algorithms or the outcomes which you are getting. Right? That model will help you. And at the end, you have to come up with your desired outcome. So this is one problem. The problem is there is one image, and in that particular image you have to find out a color of a t-shirt. How you can find out? You have to dig more. Like how many colors were there? What exactly image were there? And once you have image, You can, because we have number of colors, and according to that color, you have to define the layers. These are the hidden layers which actually gives you the outcome. Let us come with the problems. Because why deep learning is succeeding nowadays? Normal question. Why deep learning is succeeding nowadays? We have algorithms that is there from 1980s in books. Why deep learning is there nowadays? Any guesses? No guesses. Because we usually deep learning actually gives us permission to dig more. Once we dig more, we'll get accurate result. Only accuracy is the term which bring deep learning into the picture, because we are getting good accuracy with the help of deep learning. So accuracy is the only result which help deep learning to come into the picture, right? Then this is a brief history. Brief history means a normal history, because deep learning is there in 1958, because we have perceptron at that time. We have learning machines at that time. And machine learnings were increases. We have back propagation algorithm in 1974 in books, in theory. And slowly, gradually, if we can talk about SVM, that is there in 1995. Enhancements of SVM will come into the picture, and those enhancements will give us more accurate result. So this is a general history, because as far as theory is concerned, from 1958 we have a theory of learning. Like we can train a machine that will be trained and gives us some outcomes, right? So this is a brief timeline. This I captured from the web, and you also will get from the web. This is a timeline of deep learning, and actually shows that we have so many learning approaches were there. The learning approaches difference is that we have solve problems, we have self-organizing issues, we have back propagation algorithms with us. Only the algorithms will change day by day, and they gives us more accuracy, more good predictions, and more accurate results. So this is basically a timeline of deep learning. Although deep learning were not used before, I think 1950, because at that time we have learning algorithms working. Right? Slowly, gradually, deep learning is filtered out. Deep learning have number of things which is to be added in terms of functions, in terms of objective, in terms of targets. And the layers were increased, and now we have number of deep learning approaches which are there in the research market. And as far as recent progress and research is concerned, what exactly this image shows? We have the original image. What is the input? The image is the input. What is the problem behind that image? Author को क्या find out करना था with that particular image? They just want to find out how many objects were there in the image. So what they did? They apply some classification algorithm to classify between men and humans, men and dogs or animals. After that, they just classified it with the help of color. Like if it is man, then it will be lined by different color, and animals were there, they will be edged by different color. So what the author will do, they just apply an algorithm on that particular image, segregate the pixel by pixel, and they find out a specific box, right? That is just a box. Slowly, gradually, various researchers work for that particular research, and they come up with edges. I have that image also. They come up with edges, like only this particular part is the human, rest are something else. So this is classification, detection, and segmentation issue. This is there in this research, but the major input is images, number of images, and on the basis of that particular image, they find out the object, who is man and who is animal. What is there in this image or in this research? Object detection, right? Plus expression detection. What exactly the expressions are? So they classify, they segregate, and this is done by machine only. We are just giving the input, and once giving the input, we provide some database, that is a method, because we have number of images of a similar animal in the web world. We provide as an input, and then they give us some outcomes, right? What is there in this research? What is the objective of author?
references लेकर के image को generate करा.
Yes, this is reference based image generation. Reference based image generation means we have some input, we provide some references of color, of background, of design, and then on the basis of those references you will get this kind of output. This is reference based image generation. Right? On the basis of reference of color, they just change the color of a input image. So you get this kind of output. What is that in this research? This is easy, right? Background removal is easy. This is easy with the help of with your phone app. But in terms of coding, it is easy. It is not. If you have any XYZ kind of background, and if a particular image is there, you have to crop it very sharply. You have to design an edge very sharply. And manually it is fine because we are going to zoom that, we mark it, and then we remove the background. But in terms of machine, they have to design a particular graph, or we can say particular line, and line by line they have to remove a background. It is easy in terms of manual work, but it is not easy while machine is doing. Which exact algorithm the authors use? Can anyone predict it? We have so many algorithms which actually helps you out to remove a complete background other than object. So first you have to identify the object, first you have to segment it, then you have to design an edge, and then you have to remove the rest of it. What is there in this image? This is also one of the research. And in this research, what they did, they just removed the object. Is the background removal and the object removal the same? No. The algorithms were different, the approach were different, and the mindset and the objective is also different. What exactly they did? They have an image as an input, and they don't want this particular image to be there in the image. So what they did, they just captured the surrounding colors. Once they capture the surrounding colors, they put in the image the surrounding colors, so that no one can identify that this particular image is not an original image. What is there in this image? We have a scattered image, someone tear that image, and once that image is with us, they just have to plan it and create an original image. But teared image is to be converted into an original and authentic image. This is also one of the problems, which is like we have so many Vedas, we have so many papers which are already discarded, but we have to regain that particular image back. For that we use these approaches. Now, what is this there in this research? See, you all know about fake videos. This is an example of fake. What the researchers and the hackers will do? They have a video, they have an audio. According to the lip movement, they just remove the subtitles. Once they remove the subtitle, whatever lip movement is going on, they just captured it and try to represent it accordingly, whatever they want. This is lip movement kind of thing, which is done with the help of syncing of lip movement and the audio. Now, this is basically an evolution, because initially we don't have that kind of images we can do work with. So initially we have not that kind of cameras from there which we can capture the input images. Can you tell me, like, if I have a video, can I do all these work on that video? Yes, we can, because video is basically a step-by-step work of an image. Like all the images were there, and we have number of images in a single video. So initially we have that kind of images, so we can't do anything with that kind of images. If the camera quality is good, if the image quality is good, then only we can lead to the best good outcomes if we are working in images. Now, what is that? This is image to image translation. Like we provide input a number of images, we provide a kind of scenario of a particular city, and at the end they give you a number of different images which are not existing. This is image to image translation. What is this? This is unsupervised. What is there in this research? Can anyone tell me? We have number of faces of an animal, of one animal or a different animal. What we can predict? with this. This is an unsupervised. The previous one is the supervised one because all the images are more or less similar. But here we have unsupervised images. We have different images of different animals with some kind of signature and the eyes. And with the help of that, we have to predict which animal is it. It is that. So this is unsupervised research, and in this research, the different images were provided to the machine, and once the different images were provided to the machine, and on the basis of that, we have to predict that what exactly images it is. Now, this is something new because that is based on images, based on input, based on machine learning, and they come up with some outcomes. What is there in this image? All these three are different images or the same images? Same image. Why? Because three are same, the background is same, that is why they all are same images.
Different.
No, they all are same. They all are same. Now what is the difference? 10.
Different angles.
Yes. Image, the environment, the background is same, but the angle is different. Because that is clicked by a different angle, this is clicked by a different angle. A little different angle. But once we click this image, this grill will come in each and every image. Once we change the angle, this grill will come. But there is a flaw. This is the flaw. If you zoom that image, this will not properly altered, we can say. This is not properly modified. Because while working with the image, we have so many issues. We cannot work properly, and usually they will not give us 100% and accurate results. So while working with the images, we usually face these kind of common problems. Because tools never have a common sense. They remove according to the algorithms, not with the sense. They alter or they prepare an edge according to the algorithm, whatever you provide to the machine or whatever you provide to the model, not with the common sense. They never ever remove anything else. They cannot explain you what exactly they remove it or what exactly they have. That is why we have explainable AI nowadays. We have explainable AI. Do you know about it? Explainable AI basically gives you a complete information what exactly that algorithm did, and on the basis of that result, what exactly is the outcome, what exactly is the prediction, because they explain it. Like that is not black box nowadays. We have input, whatever black box things is to be going on, that is to be explained by that particular machine. So as that is image work which is going on in research, but not only images there which we can work with learning approaches. We can work with text also. Do you know about it? Like we have email, and whenever we write to reply any email, automatically some sentence comes into the picture. What is that? That is also learning. That is also deep learning. Why is that deep learning? Like if some mail comes to me from some XYZ, once I write dear, it comes XYZ or what? Usually it comes XYZ. If whatever email is coming from any X person, once you write dear, automatically X arrives. That is learning, that is deep learning. Because whatever email you have, whatever email ID you have, according to that particular services provide you a response of it. Like once you write, hope you are, they complete the sentence. That is a blur sentence, but yeah, they complete the almost sentence. That is the working with text. That is there in the research. We have key phrasing, we have filter technique, we have just deciding what exactly the next word is with the help of text. Right, that is there in research. We have searching issues with the, like our browsers work, how the browsers will work, do you know that? Browsers have their own database. Once you type Apple, they gives you everything about Apple. Not only for the iPhone Apple, but the fruit also. What is that? That is text working. So this is some issues which are going on with the text imaging. Then this is like summarizing. Have you ever seen any news article website? What is there in the summary? If you read summary. See, whatever words which are coming, just provide one sentence in one language, and they gives you a different languages form of a particular sentence. That is text translation. How many translated languages we have? How many translated languages we have? We have number of languages. Do we have Sanskrit? No, we don't have. What is the basic language which Google covers in their list? English? English is not our language. Hindi is there? Tamil is also there. Tamil is there. Tamil is the listed by Google that is a language of India. Anyways, so we have number of languages. This is just to check the quality, and this is one document which is there in the research. They have some values, and on the basis of those values they come up with some findings that I captured from the research paper, and this is the research paper which is written over there. They gives all lawyer reviews on one policies. Like each and every lawyer have their own views, own reviews, and on the basis of their survey and how they collect the survey. They collect the survey manually. Like each and every lawyer have some own comments, own views on a particular policy, and on the basis of that they collect some survey. On the basis of that survey they decide some parameters and they come up some findings that this particular policy is good or bad, or it is reasonable or not. Then this is based on legal document analysis. This is done by one researcher. They fetch some documents of different domain, and once they fetch the document, on the basis of that they categorize as what is the reason of using that particular document, what is the requirement of that particular document, because some findings are sometimes useful for the future researchers, like why we use that particular data, why it is required and how it is useful. Right? Then this is example of text generation that we have in emails also, because while writing an email some text are automatically generated with the help of tool. What algorithm is behind that particular text extraction and generation? We have so many learning algorithms, but specifically for text we have a specific algorithm. What is that? Do let me know after finish. Anyway, this is review generation. Do you know whatever reviews were there on the website, they are actually written by a human? Sometimes it is okay, but sometimes it is not. What usually websites will do, they fetch some reviews and they paste it on the website. They link some reviews with their websites and they generate it automatically. We have tool for collecting reviews from websites too. This is one example. Okay, still we have so many problems with what is chatbot? What is chatbot? Bots with which?
Answer to the prompts.
Answer to the bot.
Prompts.
Like if I ask to a travel website to answer me some points, automatically one pop-up comes. That is chatbot. That actually tries to chat with me. And that is good or bad? That is good. It gives you all answers. Exactly no. They never gives you all the answers because that particular chatbot is trained with some few answers. How may I help you? You may be searching for this particular package. Or if you are using this package, then what is the travel cost? That kind of answers are already written in the chat. Like we have chat GPT. Okay, fine. What is the problem with chat GPT? Okay, they have information only before September 2020. Fine. They work with text, right? They deal with text. Do they deal with images? No, they are not. They are planning. That is there in the research scope. They are planning. But do you know they have a specific pattern of answering all the questions? Yes, they have a specific pattern. They just answer you in a specific pattern. What is that? The pattern is trained to that bot. The pattern is trained to chat GPT. If this is the same pattern, you have to follow. Whatever they answer in a specific pattern. They don't have a different pattern. Once they change the pattern, maybe the answer will change. But usually if you regenerate it, they follow the same pattern. That is the problem with chat GPT. Anyways, so the bot have a specific problem. They generated by intelligently. They are designed intelligently, but usually they cannot answer you completely. They just answer you few things which is feeded into that chatbot, and that is the problem with chatbot. This is also one of the research domain where the students can work. Like chatbot can at least answer or at least question the person and then respond you back. Then we have so many problems with text, with images, and with multi-models. What is multi-model? Like for solving a particular problem, we design one model, right? And what is multi-model? Working with multiple models, working with multiple objectives. One data set, so many algorithms and multiple models. Like coming up with more solutions. Once we have an image, you want to check about the object, you want to check about the lip movement or the video or different requirements which you fetch from a particular image, as well as the text which is written over the image. That is multi-model, like using multiple models for solving a particular problem. Right, that is multi-model. And we have number of issues which comes with multi-models. And these are the issues. Issues are like we have image captions which is generated. That sometime image is telling or video is telling something else, and the captions which are coming, which they are something else. That is also a problem. And because sometimes we all are digital footprints. Sometimes these digital footprints cannot, you can say, give the outcomes in a better way what we are expecting, what humans are expecting. Because 100% is never matches. So these are the problems. These are basically the research problems which we have with images, text, and multimodal. Then what is this? This is also one of the research. This is one image which is given to a tool, and this image, what exactly this image has to provide? Image to text conversion. We have text to text conversion. We have voice to text conversion. We have video to text conversion. Do we have image to text conversion? Right now we don't have, but sometime if you give an image to Google, it gives you a parallel similar images, not the text. Right? So this is one of the research which is done by a researcher, and they provide one image to the model, and after that model it gives some text, and almost it is this particular tool is working only 40% accurate. Only 40% of accuracy is there. And if the researcher is still working on this particular problem, then maybe after a big research they come up with an accurate result, 80 to 90%. But this image shows what exactly is there in the image. Like whatever is there in the image, they are predicting somewhat similar. The outdoor market, the shopping, all the vegetables and the fruits. Few results are accurate, but not the all results. Now, what is this? We have input as an image. What is the outcome? After providing an image, we are giving a text outcomes. What kind of image and what kind of bird it is. They are telling what kind of bird and what is the color or the different thing which is related to that particular image. This is also one of the research. This we all have in our phones, right? What is that app? We just designed on a paper, on an A4 size paper. Click it and it gives you a digital image of that particular page which you have designed on a A4 size. So what is that app? That works perfectly. It never gives you an accurate result. But sometimes, yeah, just to create a digital copy of a particular sketch, you can use tools. We have tools for that. They gives you an accurate image. Whatever you sketch, the image will be generated. A proper image with colors that is generated. Now, speech also have some issues. We all have Alexa at our home. More or less, speakers at our home. Do they work perfectly? Why? Reason? Sometimes they're not able to recognize the voice. And if internet connection is working fine, sometimes they capture the other's voice also. Outsider's voice also. And you know what Alexa used for some crime investigations too? That anomaly detection I'm talking about. That anomaly detection issues were solved by these speakers which captured the voice, and after that they recognize the voice whose voice it is. Then this is speech recognition. This speech recognition is actually, we have a video, and on the basis of that video, what exactly the lip movement is, that they are converted into text. Whatever images we have, those images, or we can say that whatever video we have, according to that video lip movement, they just recognize what exactly text. We have some tools which actually, whatever you're telling, whatever you're speaking out, they just convert it into the text. We have number of apps for that. Even data they captured with the help of sensors, they captured it and they provide data. In terms of data, they provide to the centers. Car control, the automatic car control is one of the example of AI. We have automatic car controls there in the market, and these are the problems which are there in terms of security with AI. Right? We have security is the major concern nowadays because AI is growing like anything, and security is the major term. How we secure our devices? Can anyone tell me? You all have smartphones. How you secure your smartphones? With the help of password. Password can crack anytime and easy. What else? Biometric security is there. What other things? Like these are the things which we secure our devices manually. But what about the software and the hardware terms? Because you are always on the web, right? Once you are on the web, you are vulnerable. How you secure your mobile phones and the smartphones through the web? Firewalls. You can use firewall on your phone. No.
Authentication.
Authentication is fine. That is manual one, just like a password. Antivirus is one way. You can secure your smartphones with the help of antivirus. Can you stop any attack to come into your mobile phones? Because AI is growing like anything. They have number of attacks every day. They have different patterns every day. And once they have a different, in the previous years, whatever attack lands into any web, they have a specific pattern. Pattern means they have specific signatures. They corrupt notepad, or they corrupt Word file, or they corrupt some folders. They have a specific signatures. But now AI is having a different signatures. AI is actually helping attackers to create an attack in a single movement. And once they landed into your mobile phones, can you save your mobile phones? No, you cannot. Like once any spy comes into your phone, then you are trapped. So with the help of security or AI, there are so many issues which are actually like, can you judge a difference between an original image and a fake image? Is that possible? Okay, tell me how it is possible that this is the particular single image is the original image and this is a fake image.
AI images are smudged sometimes.
Much?
Smudged. And when we generate image with the help of AI, sometimes some portions are smudged and it is mixed.
Yeah, they are mixed. How we can find out the mixture? So, see, naked eye cannot see easily some issues, but tool can do that. Like your antiviruses can do that. But there are so many other things. Like if the image is heavy, you can at least predict that this particular image may be a fake image. So that comes with the security issues. Image has so many issues. If they land to another phone and they create a spy issues or some other issues. What is spyware? What is spyware? Spy is hiddenly monitoring something, and that comes with the help of AI. Like AI can generate different attacks which can attack your devices and access. Although we are not celebrities, so that anyone can come and hack our phones, but still to just protect ourselves, we have to take care of it. Whatever device we have, we can avoid the usage of AI to prevent. Like usually we go for default password. Do we go for that? Default password. Usually we have to avoid that kind of scenario. Don't go for default passwords because the tools which is there in the apps which are there in the mobile have some techniques to fetch everything, and they can provide other apps a backdoor entry. Once they provide a backdoor entry, your phone or your devices will run. So these are the issues which are there. Security with AI, and the issues are like expansion, attacks that we talked about. Then we have number of threats which are coming into the market. We have different kind of attacks. We have white hat attacks. We have grey hat attacks. We have black hat attacks. What are black hat? They are terrorists. They are not legal. They are illegal. Black hats are illegal. Grey hats are which work for preventions. And if they work for preventions, they have some permissions to come into the website or lead or get into the scenarios and at least know about how to prevent a particular error. They are grey attackers. So usually the grey attackers are at the prevention side, and white means they are open to open. So these are some issues which comes with security with AI, and because we need data which is to be used for ML, AI and deep learning. And data we have, like if we use deep learning, we require data, and that we discussed, right? The data, whatever we are using, we should use that particular data which is the authentic data. If you are not using the authentic data, then whatever predictions you are doing, that is completely waste, right? And for that, what you have to do is you have to segregate the data sets, or you have to select the data set accordingly. Like if you're working on images, then we have some specific data which is actually available for the researchers to do a research in terms of images, in terms of speech, in terms of text and NLP, that is natural language processing, and some geographic data. So each and every data set, some data are authentic data which is available on the website, which are free of cost available, and sometimes they are updating that data set also. While they are updating the data set, you can use that data set, use the ML approaches and come up with some good predictions. Right? And these are some important data sets which researchers quote. Like because the researchers are using that particular data set and quoting them into their research. Like if you go to any research article, sometimes they actually provide the source of the data, sometimes they didn't provide you the source of data. Why they didn't provide you the source of data? Because sometimes authors are not sure about it that this particular data is authentic data or not. That is why they are not providing that data into their research articles. Once the data is given in the research article, they will quote it like this. Like in that particular year, this data is to be used for that particular approach or that particular model. Now these are the data frames. We have number of data frames, or we have number of platforms which actually helps you out to use the learning algorithms. And right now the TensorFlow and the PyTorch, only these two platforms are running very fastly. Can anyone tell me why is that so? Otherwise I'll tell. Do you know about PyTorch? PyTorch is compatible with Python. And because now our students are working in Python, so they are more comfortable with PyTorch. And why TensorFlow is majorly a part of current research scenario nowadays? Because TensorFlow is giving a user interface, a good user interface. And that because of that interface, we are not going to the Python side. We have interface. Once we have interface, we just have to provide the input. We have to select the algorithm and we have outcomes. But PyTorch is actually helps you out to comes or to float into the coding side also. And these are the applications that we all know. These are related with learning, machine learning and artificial intelligence. Like self-driving car, news aggregations, fraud news that we all talked about. Right? These are the applications where the machine learning is actually used. And these are some trends which are going on, and this I captured from one government website, and these are the latest research trends which are there with the deep learning, right? Because COVID, as we all know, like MLM framework competition, we have so many frameworks in the market. PyTorch we have, TensorFlow we have number of other platforms also. What is the competition behind that platforms? Because each and every platform want there to be used more. That is the major competition. And how they have to improve themselves, that is their issues. But that competition is also beneficial for the researchers because PyTorch is related with Python and TensorFlow is hardly bothered about the coding. So that is major competition. Then we have analysis, forecasting, explainable AI that we talk. What exactly explainable is? While doing any kind of research, we usually in ML or deep learning, we usually concern about the problems, the process and the outcomes. We usually concern about that only. We have algorithms, we hardly bother about the algorithm. We are bothered about the outcomes, right? But explainable AI is something which have an explanation of each and every outcome. Like if my algorithm is predicting this particular of accuracy, why and how it is predicting, that is explanation. They explain by themselves, like algorithms step by step, work, procedure, platforms and models, what exactly they are doing, that is done by explainable AI. And researchers are working on it because they really want how chatbot is working, how ChatGPT is responding. That explanation need to be actually comes out into the picture. Like because we need explanation why this kind of explanation is coming out. From where this GPT is getting the responses. We don't know about it. They have a specific database and on the basis of that database, they are giving you some responses, right? Externally, yeah.
Particular piece will perfectly fit into this image. Like how would it be?
See, once you provide an input to the machine, they work pixel by pixel, right? Once one pixel have a specific color, they just capture into the database. When they lead to the next pixel, they search for the surrounding neighbors. Once they know that this particular color is in the neighbor, which is the best suited neighbor color, they opt that color. So with the help of that intelligence, they opt that color. And whatever output that particular image is provided to you, you just scan, you just zoom it, and if there is some issues, then you can again, what is regeneration? Regeneration is providing that particular image again to the machine. They remove all the errors and then come up with a good solution. That is optimal solution. Optimal means a good, best solution. So pixel by pixel usually algorithm work. They capture the neighbor color image, and once they have a neighbor color image, they just matches which is the best color to be put in that particular space, and then they put that.